Thank you, Jose, for the invitation. Hello, everybody. I'm going to talk about Arctic changes in Europe. But before that, I consider the changes in more general sense. It's very well known to us all that Arctic temperatures have been rising more than the average temperature in the globe. And this amplification is pretty well documented. And we are seeing quite big changes now in Arctic sea ice extent, also the mass of Greenland ice sheet, the outlet glaciers, for instance, in the mountain glaciers, they are melting in nowadays in Norway, although before, let's say 10 years ago, they were still expanding. Sea level rise that has been accelerating during the recent decades. And we see the melting of permafrost and disappearing of multiple lakes, especially in hotspots like in Siberia and in Alaska. And we see also big changes in Arctic lake communities. These have been documented using sediment proxies. And it's very well known and widely spread phenomenon. Nevertheless, when we read about these changes in public media, we often they are described in a very, very dramatic sense, and it might well be that they are that dramatic. But on the other hand, we have to remember that usually the records of these changes are pretty short, and I think it's especially the responsibility of the paleo community to expand these records and demonstrate whether they are so unusual as is often thought. They are also sometimes a little bit exaggerated, I think so, like Al Gore in one of his latest speeches was speaking about that we are already seeing the complete disappearance of the polar ice caps right before our eyes. So I think this is a little bit exaggeration. And sometimes we also, as a scientist, I see very strange statements which are then taken very seriously by the public media and audience, and sometimes even great thinkers like Leonardo are coping this statement and saying that Homo sapiens may be extinct soon. Who is this Leonardo? It's Leonardo DiCaprio. Anyway, I think it's very important for us as scientists to avoid unnecessary exaggeration and acknowledge uncertainties in our records. I think there are various reasons for that. Climate change is not going to pass away for decades, so we need science, climate science for many decades ahead, and we should be very careful that it maintains its credibility. Also, I think that the means to mitigate global warming must be updated in a continuous manner. And so in that respect, I think we shouldn't stuck to only one sort of explanation per time, but be open to multiple other explanations. We need public support in order to fight against global warming, and we should be very careful that we do not lose it by exaggeration or just not acknowledging the uncertainties. There is a good article now appeared in environmental communication that expresses two things that might be dangerous when we take a too alarmistic or doomsday strategy in our communication. And it easily puts us aside from the public and can affect, can be actually effective in the sense that people become fatal, they become more conservative, and that may not be the good strategy. I still think that we need people like Jim Hansen, but maybe we need also various other opinions and especially honesty. Because there are quite a lot of uncertainties, especially when it comes to Arctic changes. Our level of scientific understanding, as acknowledged by IPCC, is pretty low regarding many forcing factors. And especially when we go to feedbacks, our knowledge is even lower. I give two examples now. Black carbon soot and its impacts on Arctic environment and the rapid changes in Arctic environment is quite crucial, and there has been a lot of new studies saying that even 70% of the Arctic warming since 1976 can be explained by aerosol forcing. This is a brand new study in Nature Geoscience, and these people claim, using simulation studies, that black carbon has contributed to 0.5 to 1.4 degrees Celsius to Arctic warming since 1890. So we still have a lot of other things in the play when it comes to explanation of many of these Arctic phenomena. I'm pretty sure that greenhouse gases is of course driving force behind, but still we do not need to forget that there are many other explanatory factors. Also, there is a brand new study in Geophysical Research Letter documenting that actually this Arctic amplification has been most rapid in the early phase of the 20th century. So it was clearly more rapid then than during the last 30 years. So this, of course, bears a lot of implications to forcing factors. So what was the cause for such a big change in the early 20th century? These are questions that we simply have to tackle, and I think paleo science can provide good answers and good insights to this discussion. So why is the last 2,000 years so crucial from the perspective of global warming? I think they are crucial because boundary conditions of Earth climate has not changed so dramatically during this time period, and there has been a lot of variability, as I will show in my short presentation shortly. And there are possibly several climate oscillations that have taken place during the last 2 millennia. We have seen this picture many times already in this meeting, and if it, of course, the European Arctic changes are parallel with the overall changes in the northern hemisphere, in the Arctic, circumpolar Arctic. On the other hand, there are some regional characteristics for the European Arctic that I will tackle shortly. But first, focusing on the recent warming during the recent past, European Arctic seems not to be such a hot spot than the continental Siberia or many parts of Northern America. So in Europe, the changes have been quite modest. On the other hand, when we go back in time, we see that the oscillations during the past 2 millennia has been probably most pronounced, especially in the European Arctic and in the North Atlantic climate regime. This is a brand new study by Håkan Groth. His time series of 3-ring time series from the Lake Träsk area in northern Sweden, the blue one. And he was able to demonstrate using some new techniques and collection of trees in a more careful way than in his or others' earlier studies, that there has been quite a big oscillations, especially the medieval warm period is very pronounced in this record, and it's much more warmer actually than the very recent decades. Also in some lake sedimentary records, this is a laminated lake sediment record from central Finland. The medieval warm period seems to be a very unique time period in the history of lakes. It was characterized by organic deposition. Usually the wire thickness, as is indicated here, it's caused by spring flooding. And these people claim that because there is a lack of, almost complete lack of clastic sediments, the whole Finland, the southern and central Finland must have been predominantly snow-free during the medieval warm period. And that's the reason for the very, very big organic sedimentation. And that's, of course, quite a big change. In glacier records from Norway, various glaciers from maritime to more continental, we can see that there has been very pronounced changes in the past, and especially during the Little Ice Age. The ice spread of these glaciers was most pronounced during the Little Ice Age. And it has been a very, very sort of widespread phenomenon. Also, we see these similar type of patterns in Greenland ice records. We see them in marine records in a North Atlantic Sea area, where people have, using different proxies, I have no time to go in detail with these, but they have separated certain phases like the Roman warm period, Dark Age cold period, the classic well-known climate events, the medieval warm period, and the Little Ice Age. And these people, especially in these records, the medieval warm period as well as the Roman warm period are very clearly seen according to the authors. But these are not, these oscillations that I mentioned are not only typical for the Arctic part or the northern part of North Atlantic, but they are very widely spread all over the Atlantic Ocean. And here are the records from Bermuda and West Africa that show very similar patterns than the records from the Greenland ice core. So these are widespread phenomena. And in this record of Western Africa sea area, these people claim that actually Little Ice Age has been the most pronounced event during the whole 20,000 years record that they derived from the sediment. So when we speak about climate oscillations during the last 2 millennia, we are not dealing with very something minor changes or fluctuations. We probably deal with quite pronounced changes that need to be examined more carefully, and the explanations of which must be paid attention. Also in some Arctic lake records we see a very pronounced Little Ice Age cooling and medieval warm period. So these are widely spread. But what is less known is actually what has taken place in the moisture conditions during these oscillations. As Jonathan Overberg said, these temperature comparisons between modern and medieval warm period, they are passé a little bit, and we should focus more on issues like precipitation and moisture. So what we have done recently is that we have collected from peatlands records that reflect very well summer moisture conditions. We are reconstructing the water table fluctuation in these peatlands. And they seem to respond especially to the total seasonal moisture deficit, which is precipitation minus evaporation. And what we have done is that we have collected cores from different peat bogs. We have analyzed them for macrofossils, with a very, very detailed manner. We have high-resolution records and probably the mostly carefully dated proxies by radiocarbon that exist from the Northern Europe at the moment. So we have, for instance, here in this particular peatland, we have more than 50 AMS dates for the last 4,000 years. We first calibrated our proxy against vegetation dynamics in these peat bogs. We modeled using general additive modeling the response surfaces of modern day vegetation along the water table, and we saw that there are clear distributions according to this important gradient. After that, we created transfer functions for vegetation percentages that were determined from the peatlands and water table depth. And this transfer function seems to work pretty nicely, and we have a pretty low prediction error in those. And this is the record then what we derived during the last 5,000 years from this particular peatland. And we see quite marked oscillations, and it's interesting to compare this with other records. So we did so, and this is a quite recent summary synthesis of Pakke and his co-authors, where they summarize different proxies from Greenland ice core, from ice rafting record from the North Atlantic, the pond record, and then some other proxies from the glaciers that reflect mostly the North Atlantic oscillation pattern and especially the winter precipitation dynamics. And we can find that in all these proxies we can find a similar type of oscillation dynamics, which probably reflects the NAO dynamics and especially the winter precipitation dynamics. If we compare then our peatland proxy against these other proxies, we see that it fits quite nicely with the overall North Atlantic records, and we see similar type of changes. Especially clear and also somewhat surprising for us was the clear connection between our peat proxies and the pond cycles. And this is quite interesting because it gives an illustration if pond and colleagues are right that it's probably the solar influence that have sort of been the major driver of these oscillation patterns and ocean circulation patterns that are affecting these ice rafting phenomena. It seems that we are dealing with similar kind of circulation dynamics in our record. If we look at this record in a little bit more detail, focusing only on the last 2,000 years, we can distinguish certain phases like this Roman warm period when there was increased dryness in our records, then the Dark Age cold period, medieval warm period, dry again, pretty wet little ice age, and then the recent warming that seems to be different than the rest of the records in the sense that usually warm and dry go hand in hand in the past, but this dynamic seems to have changed during the recent past, and we think that it's basically that the natural forcing has shifted to anthropogenic, and also this aerosol forcing can have a big impact on the precipitation patterns in our study area. This is in more detail the last 2,000 years of this very same record, And we can see that interesting is also that the little ice age that is usually considered wet throughout. It's not wet in our record throughout, but it's becoming more drier in the end of towards the end of the little ice age. And then the shift to present conditions where warming as well as moisture are increasing simultaneously, which is quite unique compared to the recent past. I think my time is limited, so I skip a few slides, but I just said that there are multiple explanations for these variations. One is solar variation that modulates the atmospheric circulation patterns, but I skip. Then the other one, the more, let's say, more recent one that has been now quite impressively documented is the North Atlantic oscillation, where people did a new expanded NAO pattern record from the tree rings that were critically positioned according to the both poles of the NAOs, or so north and south, and they then reconstructed this NAO pattern more back in time and found out that especially during the middle of a warm period, it seems that the NAO pattern seems to have stuck in the positive mode, and that has caused so the westerlies to be more pronounced in European Arctic areas and caused very mild winters and especially affecting the moisture balance in winter that's reflected in glaciers and many other environments. But then I go to my conclusions. This is sort of summary that we have multiple forcing factors. One that I didn't mention is CO2. There are now new studies showing that especially during medieval warm period, CO2 concentrations might have been higher than previously thought. This is a stomata record from Holland, and it has warming or forcing potential that is about the similar magnitude and solar forcing, and so it should not be neglected when we think about different forcing factors. And then we see clearly these shifts and oscillations in moisture patterns, and especially the little ice age is interesting as it's not throughout wet. It seems to be dry towards the end of the period. And of course, I cannot give a final explanation what is causing these oscillations, but it's certainly worth of plenty of future studies. Thank you very much.